welcome back into the channel. If you're new, please make sure that you subscribe, like the video, and leave a comment to just show your support. If you're looking for a tutor, you can go and check capetowntutors.com. We have plenty of help available in terms of tutors for all types of subjects, not only maths. Go on there, you will see everything that you need to check and all the content details that you will need. In this video, it's basically the first video of a series of sequences and series questions. So we take it back to 2008 question papers right up to 2022, and we're going to keep on adding on more of these videos. So make sure you tuned in to be checking more videos to make sure that you're fully revised from all the years so that you can get more familiar with the content. Anyways, without further more to do, let us get into the questions. So the first question that we've been asked here, it says, consider the sequence 1/2, 4, 1/4, 7, 1/8, and 10. Then it says, if the pattern continues in the same way, write down the next two terms in the sequence. So they've given you 6 terms here. Now, it's not normal that they give you 6 terms for a pattern. Typically, they'll give you 3 terms if it's a arithmetic sequence or a geometric sequence. And if it's a quadratic sequence, they tend to give you 4 terms, right? So those are certain clues that you can get. But if you look at this one, there's 6 terms that have been given. But you can see that what you can see here is that there's a pattern that forms, for example, here. And if you look at 4, and then you look at 7, and you look at 10. So every time you skip a term, you see there's a pattern that forms there. So 4, 7, 10. So meaning that the next term would be 13. But before 13, you would need to have a certain number so that it can flow in the same direction. Now let us look at the other sequence that's forming, which would be 1/2, 1/4, 1/8. So this is at the top you see 1, 1, 1, but at the bottom you see 2, 4, 8. Now we can see that would be a geometric sequence. Now the next term, so if this is 1/2, 1/4, and 1/8, well, if you look at these, to get to the next term, you basically have to multiply by 2. So there's a multiplication of 2. So if they're asking for the next terms, then the next term, it means that you need to multiply the denominator by 2. So then the next term would be 1/16. And then the term after that would follow 4, 7, 10. And so that would be 13. And that's how you'd solve that question. Next question says, calculate the sum of the first 50 terms of the sequence. Okay, now if you look at this sequence, we can actually start by separating it, having 1/2, 1/4, and then a 1/8. And then the term that followed after that was 1/16. And then we can look at another sequence here, which is 4, 7, 10, and the term that followed after that was 13. Cool. Now, if you look at this one, this is a classic arithmetic sequence because there's a difference of 3 between all the terms. Now, if this sequence goes on like this up to 50 terms, when you get to 50 terms, you're going to have 25 arithmetic terms and also 25 geometric terms, because here what you're basically doing is to multiply by 1/2. So at the top you multiply by 1, at the bottom you multiply by 2. So you're actually multiplying by 1/2 to get to the next term, which means that it is a geometric sequence. So you have 25 geometric sequence terms, and then you have 25 arithmetic sequence terms. So what you need to do is to apply firstly the formula of an arithmetic sequence. So a formula for an arithmetic sequence is basically Sn is equal to n/2, then you open the bracket, then it's 2a plus d into n minus 1. Close the bracket. Now, we're only going to 25 terms, and then the other 25 terms are going to come from the geometric sequence. So then we're going to say, well, S25 is going to be equal to 25/2. Then you open the bracket, then it will be 2 a, well, a is the first term, so the first term would be 4, then plus d. D in this case is 3, because you can see that the difference between terms is 3 into n minus 1, n is 25, and then minus 1, and close the big bracket. Okay, so then to work that out, I'll just put on my calculator. Make sure you put on yours. We're no longer doing the NBT video, so we can actually use our calculators now. So that's 2 times 4 plus 3, open bracket, 25 minus 1, which is just 24, and then close the bracket. The answer that I'm getting there using the calculator is 1000. Okay. Then let's get into the other one here. So now the sum of a geometric sequence is Sn is equal to a to the power r. So a, open bracket, r to the power n minus 1 divided by r minus 1. So to substitute then in there, we'd have S25, because again, it's only 25 terms of a geometric sequence. Then our a is going to be 1 over 2, and our r here is also going to be 1 over 2. And then that would be raised to the power of 25, subtract 1, divided by 1 over 2, minus 1. So if you put that in the calculator, it's going to be 1 over 2, 1 over 2 to the power. So it will be to the power of 25. Minus 1. All divided by 1 over 2 minus 1. And that would be equal to 0.999. Now, if you round that off, that is basically equal to 1. So then the sum of 50 terms would be, if we add up the sums of both, so it would be then the sum of 50 terms would be 1000 plus 1, which would just be 1001. Would be 1001. Okay, cool. So we've done 2.1.1 and 2.1.2. Let's now move into 2.2.1. So in 2.2.1, we given a sequence. Here they've given you 4 terms. Now when they give you 4 terms, normally it's a quadratic sequence. So it's 8, 18, 30, 44, and they say write down the next 2 terms of the sequence. Well, let's write it down. So 8, 18, 30, 44. Now, let's look at the differences. The difference between 18 and 8 is 10. Difference between 13 and 18 is going to be 12. So it's 12. It looks ugly. And then the difference between, so that's 44, sorry. 44 and 30, that's going to be 14. And so we have a constant second difference of 2. And then it says that we need to write the next 2 terms of the sequence. We'll write down the next 2 terms of the sequence, maintain the same difference. That's 16. 16 plus 44. Well, 16 plus 44 is going to give you 60. Then we're going to have a 2 here. And then that's going to give us an 18. And 60 plus 18 is going to be 78. So when they say we need to the next 2 terms of the sequence, it's basically going to be 60, and then it's going to be 78. Next question says, calculate the nth term of the sequence. Well, the nth term of a geometric sequence is equal to Tn is equal to an squared plus bn plus c. Now, let's plug into this equation here. So to plug into this equation, we need to find a, b, and c. Now a, the way in which you find a, would take the second, so the constant difference would be equal to a 2a, And then the first difference, which is 10, is going to be equal to 3a plus b. And then this term here, 8, is going to be equal to ba plus b plus c. And then we're going to use these equations to solve for a, b, and c. So to solve for a, we're going to have 2a is equal to 2. 2 is equal to 2 means that a then would be equal to 1 because you divide 2 by both sides. Then we use that information to solve for 3a plus b because we have 3a plus b is equal to 10. Now, if we know that a is equal to 1, that means it's 3 times 1, so it's going to be 3 into 1 plus b is equal to 10. That is going to be b is equal to, well, 10 minus 3, which is equal to 7. And then lastly, we're going to have a plus b plus c. A plus b plus c is equal to an 8. And so a was equal to 1, b was equal to 7, and then c is what you're looking for, and so that's equal to 8. So you can see there that we have 1 plus 7, which is equal to 8, and if it crosses the equal sign, it becomes 0. So then c is equal to 0. And so the equation of the nth term is going to be Tn is equal to a, which is 1, so it's just going to be n squared plus bn, so that's going to be 7n plus c, so plus c is just 0, and so that's where it would end. So then that would be our equation. Tn is equal to n squared plus 7n. All right, cool. Let's move into the last question. So the last question says, which term of the sequence is 330? Okay, cool. So then it means that if Tn is equal to 330, which term of the sequence is that? So in other words, 330 is equal to our nth term, and so we need to find n. So then to find n, what we need to do is to make 330 cross the equal sign, and then we're going to have n squared plus 7n minus 330 is equal to 0. And then we need to find terms. So that's quite a big number that you got over there. So in order to solve this, I'm going to use my calculator. So I'm going to go in my calculator, and then I'm going to go mode, I'm going to go equation, and the equation that I'm looking for is a trinomial, which is number 3. So I'm going to press number 3. And then for my a, because my a is, in this case, would just be 1, so I'm going to say it's 1, press equal sign. For b, I'm going to put 7, and then for c, I'm going to put minus 330. Then I'm going to say equals. And then after I've put in these, it's going to give me the x value. So the first x is equal to 15. So I can use, so the first x is equal to 15, and then the second one is equal to minus 22. Okay, cool. Now, when we have that information, we can then say, well, n minus 15, and then the other n will be plus 22 is equal to 0. And then to solve further there, we're going to have n is equal to 15, or n is equal to negative 22. But now in this case, because we're looking for the term of the sequence, well, our terms of the sequence not go down to negative 22, so they always go up. And so we can conclude then that n would be equal to 15. All right, cool. So this is an easier way of finding factors with just using a calculator as opposed to trying to figure them out, because 330 is such a big number to be finding all individual terms that will be able to give you that set there. But anyways, that's it for this lesson. Check out the next one as we solve questions from November 2009. Cheers for now. See you in the next video. Bye.